Welcome to The Explainer. Okay, today we are tackling a huge topic. It's a technology that honestly sounds like it's straight out of science fiction, but it is right on the verge of changing, well, pretty much everything. We're talking about quantum computing.
So let me ask you something. What if the most complex, most difficult problems facing humanity could be solved just like that, in an instant? I know, it sounds impossible, but this isn't some far-off dream. It's the quantum revolution, and it's set to really take hold by 2030. Yeah, it's coming a lot faster than most people realize.
So, what does this quantum future actually look like for you and me? Well, let's start with healthcare. We're talking about medicines that aren't just one size fits all, but are designed specifically for your DNA. Imagine cures for diseases that we've been fighting for generations, all discovered at a speed that, until now, was completely unimaginable.
Okay, and what about the global economy? This is where it gets wild. Quantum computers could potentially predict market movements with just mind-boggling accuracy. Think about that. It could help prevent financial crises and create entirely new investment strategies that are just completely impossible with the computers we have today.
And it doesn't stop there. Beyond that, we're talking about creating hyper-intelligent AI and revolutionary new materials designed literally from the atom up. So think about things like ultra-efficient batteries or impossibly strong lightweight alloys. This isn't just a small upgrade, it's a complete shift in how we do everything.
Okay, so how close are we to this future, really? I'll tell you, a lot closer than you might think. This has moved way beyond theory. What we have now is a full-on global technology race, and the breakthroughs are happening at a truly astonishing pace.
Right now, we're in what the experts call the NISQ era. The best way to think about it is like the early days of computing. Back when computers were the size of a room. They have this incredible potential, but they're still a little bit, let's say, noisy and prone to errors. But even in this early stage, these machines are already doing things that our best classical supercomputers just can't touch. And we're just getting started.
And the progress? It's absolutely exponential. I mean, for years, we were counting qubits, those are the basic building blocks of these machines, in the dozens. But just recently, we've completely blown past the 1,000 qubit milestone. That is a massive, massive leap in computing power, and it's unlocking all sorts of new possibilities.
But it's not just about cramming in more qubits. It's about making them better. See, one of the biggest challenges has always been keeping these super delicate quantum states stable for long enough to do work. But a recent breakthrough from Princeton, wow, they managed to extend a qubit's lifetime by nearly 15 times the industry standard. That is a total game changer, and it's paving the way for much more reliable quantum computers.
And as one of the lead researchers, Andrew Halk, put it, this isn't just some small improvement. This is the moment quantum computing moves out of the realm of just being possible and into the realm of being practical. It's becoming a real, world-changing tool.
What's really fascinating here is that there's not just one way to build a quantum computer. It's this frantic race between totally different competing technologies. So on one side, you've got trapped ion systems, think incredible precision and stability, and on the other side, you have superconducting circuits, which are all about blazing fast processing speeds on a platform that looks a lot like today's computer chips. It's anyone's guess which one will win out.
But, and this is a big but, with all this incredible promise of solving problems, the first major impact of quantum computing might actually be to create a massive one. The very same power that makes these machines so great also makes them an imminent threat to our entire digital world.
So, ask yourself this. What is the most important thing that all of our computers today protect? What's the foundation of our entire digital lives? Yeah, it's our security. That's right. The incredible power that could create new medicines could also absolutely shatter the encryption that protects, well, everything. We're talking your bank account, your private messages, even national secrets. A powerful enough quantum computer could make all of our current digital locks completely useless. Pooh, gone in an instant. So, because of that threat, a whole new field has popped up. It's called Post-Quantum Cryptography, or PQC. And the goal is pretty simple, but it's crucial. Build a new generation of digital locks, new kinds of encryption that even a powerful quantum computer can't break. It's a frantic race to upgrade our defenses before the threat actually arrives.
And listen, this is not some distant, far-off problem. The transition is happening right now. The US government is already finalizing these new quantum-resistant standards. And look at the market for this stuff. It's exploding into a multi-billion-dollar industry. This is a race against time, folks. Okay, so securing our data is obviously a huge piece of the puzzle. But getting to a truly useful, world-changing quantum computer, well, that still involves overcoming some other pretty major obstacles.
So what are we up against? Well, it really boils down to three big things. First, the hardware itself. Just building stable, large-scale processors is a massive engineering challenge. Second, error correction. Remember those noisy qubits? They make mistakes, and figuring out how to correct them in real time is a key hurdle. And third, the talent gap. We have a huge shortage of people who actually know how to build and program these things.
So how ready are we for all this? Well, a recent survey asked major corporations that very question, and the results are a little scary. Despite all the urgency, especially around cybersecurity, nearly half of all organizations say they are not prepared for this shift. That's a huge number. It should be a real wake-up call.
Okay, so what does this all mean for you, right? What are the next steps we should all be thinking about to get ready for this quantum era? Let's dive into that.
All right, the experts are all pretty much in agreement on this one. The absolute worst thing you can do is nothing. So here are the steps. Step 1, and it's simple, just stay informed. Follow what the big research centers and tech companies are doing. Step 2, start thinking about the risks and opportunities for your own industry, your own career. And step 3, get your hands dirty. Don't be afraid to experiment. There are actually publicly available quantum systems online you can play with right now to start learning.
Look, the quantum era is coming. There's no doubt about it. The technology is advancing faster than many people ever expected. The potential is just about limitless. But so are the challenges. So the only real question left is, will we be ready for it?